You're not able to see my screen, right?
Yes, Karthik.
Okay. We'll do a quick recap of what we saw in the previous two classes, right? So we saw array list and we also saw linked list, right? So what's an array list? It stores certain elements in a sequential manner in the memory. Right? When I say sequential manner, in the next memory blocks in our RAM, it stores like that, right? Like this. So all these blocks are sequential in memory or RAM, and we try to store an integer, and all these things are stored in a successive memory locations. So if you wanted to access any particular thing, we'll directly know the index of it, right? For example, if I wanted to access particular thing in third index, then 60 will be returned. And fourth index, this will be returned. And if I try to add something seventh or eighth index, it will throw array out of bound exception, right? But what's a linked list? Linked list is something which will store data in random memory locations in RAM. There is something called head of a linked list, and there are nodes of linked list. First element in a linked list is called head, and subsequent elements we call as nodes. Every element is connected, interconnected with one another through something called address information. For example, this particular M1 memory location will have three informations. One is what value it holds, and what is the address of the previous memory location it is pointing. What is the address of the next memory location it is pointing, right? So this is called doubly linked list. Similarly, A3 memory address holds the value -3. It also holds the value of the previous memory location, the next memory location. Two address it will hold, right? So what's the advantage of linked list? Insertion and deletion becomes very easy. Uh, Once you access the head of the linked list, you can access the remaining nodes through head only. Insertion and deletion is kind of very simple because you just have to break the links between any two nodes and insert that node in between and form a link in between those nodes. Okay. And every linked list node will hold these informations. Mandatory will hold these informations. On the downside, it take a little more memory because it holds address information as well as the value which we wanted to store. Right. So today we'll see what is a hash map. Um, Everyone, any idea about what's a hash map? Can anyone say?
It's key and value pair.
Generally, what is a map? Can anyone say? List we know, right? It stores some data sequentially. What's a map then?
Map is just a simple a key value pair.
Can you post it in chat or unmute yourself and say, or if you don't have any idea, you can just say that as well.
It's just a key value pair. A key is mapped to each value. That's what
Okay.
word map comes.
Key value pair, right? As Vinay said. So
Yeah.
map is something which has a key and it has a value, right? Like how we have a dictionary. Dictionary has some key and it has some meaning towards it, right? Similarly, hash map is something which stores two informations, right? A key is something which is kind of a representation of what value we are going to store, the actual value that we are storing, right? For example, a list is kind of a very generic data structure, right? We store information, but we don't know what type of information is that. Every time at the runtime, a user has to know like what type of information we are trying to access and have to process the data according to that. But when we use a data structure like hash map, it has a key and value. So when I say, let's say a student has certain marks, right? Let's say we are having that scenario. If we wanted to store a mark in array list, how I will store? Let's say some 5 people are getting some marks out of 100, like 73, 46, 89, 20, and 54, like, right? 5 people are scoring these marks out of 100, and like, who are those 5 people? I want to know those information also, right? Like, let's say A, person B, C, D, and E, right? So if I'm storing this as this in an array list, what I should do? I should store the marks in certain on one array list. I should store what are the persons scoring these marks in another array list, and I have to match between the indexes only, right? Index 0 should have A mandatorily, because in the index 0 of this array list only we are going to store the marks scored by A, right? Similarly, if it should match perfectly, right? This matching. If any one thing messes up, because if I am storing this 54 here and 20 here, then value of D and E will get interchanged, right? Even for small sets like this, it will be creating lots of confusion. Imagine a set of lakhs of data like this. You cannot go and map to array list like this. It is kind of very complex operation, and if you want to remove something or add something, it's kind of very difficult. You have to handle in both the lists, right? You're getting what's the problem with this kind of approach, right? So to solve these things, they have introduced hash map. So hash map, we can simply do something like this. I have a list of a hash map here. So I'll have something like this: key as A and value has 73, B and value as 46, C and value as 89, D and value as 20, E and value as 54. Right now it's very clear. Hash map stores something like this, value something like this, a key value pair. This is a key, A is a key, 73 is a value. So now if we try to access any key, if I wanted to, let's say I wanted to get a value of this guy called C, then I can just say, hey, hashmap dot get of C, right? It will get the value and see how simple this implementation become after hashmap, right? Biggest advantage of hashmap is you can store something like key value pair like this as well, right? Fine until now, right? Vinay, Anshal, Dibya. Okay.
I have a question here.
So
Like,
how this is internally implemented in Hashmap, we'll see with some example. Let's say, okay, Before moving to that, there is something called time complexity. Right? Time complexity is something how much time data is going to take. I mean, an operation is going to take for doing particular or getting particular value or doing particular process over a particular set of data, right? That's called time complexity. For example, um, let's say in linked list, right? In linked list, I wanted to access the last element. Let's say there are 4 elements. I wanted to access the last element in the linked list. I have only head information. How much time it is going to take? Let's say I have a linked list with 4 elements, right? 4 elements. Let's assume that for accessing each element, I'm going to take a time of 1 millisecond, right? So I wanted to access the last element in that particular linked list. How much time it's going to take? Yes, 1 millisecond per element. Can anyone say? Hello? It's a very simple question, I think. I have 4 elements in linked list. To access each element, it needs 1 milliseconds. So I wanted to access the last element. How much time it will take?
Last tell me 4 milliseconds.
Hello? Okay, anyone doesn't want to answer, you can post the thing in chat also. Yes.
Karthik, can you explain time complexity once again? I didn't able to hear that.
Okay, I have just started with time complexity. I was just asking, there are 4 elements in linked list. Uh, to access each element, I need 1 millisecond. To access the last element, how much time it will take? Total time it will take.
1 millisecond.
I mean, I need to access the last element.
It depends how many elements are there.
Yeah, I have 4 elements, right?
Then 4 milliseconds.
Yes, 4 milliseconds, right? Similarly, I have this same 4 elements in an array list. Now I wanted to access the last element. Again, each elements take 1 millisecond. Let's say it's an array list, right? Again, I have 4 elements. Each element will take 1 milliseconds to access. Now, how much time it will take to access the last element?
Sorry, can you come again, Karthik? 4 elements take 1 millisecond, you said.
I mean, there are 4 elements in an array list. So each element's accessing will take 1 milliseconds per element. Now again, in this array list, I wanted to access the last element. So how much time it will take?
All takes 4.
Okay, in this case, it takes only 1 millisecond. I think Dibya answered that. Okay, why it's taking 1 millisecond? Because we in array list we all access the elements with help of index only, right? So when I say last index, we know it's a 4 elements. Then I'm saying it's a last index. Then obviously we can do something like this array list, or directly we can do an index getting the index directly, right? Whereas you cannot do something like this in a linked list. Right? So because of this, linked list will take 4 milliseconds, array list will take 1 milliseconds. So this is called time complexity, right? So we represent the worst case time complexity with the notation capital O of n, right? Where n is a number of elements in the particular data structure. Right? The worst case time complexity is the worst, I mean, maximum time where it is going to take for do certain operations, right? For example, I wanted to access certain last element in this linked list. Then how much time it's going to take? It's going to take uh, n time, right? N is a number of elements in the linked list, right? N is a number of input data set. So n may be anything. If I have 10,000 elements in linked list, then if I wanted to access some last element of the linked list, then it's again going to take n times, right? Because each element will take some 1 millisecond. Now I having 10,000 elements, then it's going to take 10,000 milliseconds. So this time will always depends upon number of input of number of elements present in the linked list. So we represent this as n, where n is the number of elements. Okay? Because the time complexity or time taken to access the last element depends upon number of elements present in the linked list. You're getting my point, right? What I'm trying to say here. Whereas, what's the time complexity of this array list? Let's say I wanted to access the last element. What is the time complexity of this array list? We say it's an order of 1, right? Because irrespective of the size of the array, I can access the last element in the constant time, right? Because we always know what's the last element through its index.
Karthik, I didn't understand how did we get 1 millisecond here?
No, 1 millisecond is just an assumption that accessing each and every element in that particular list takes 1 millisecond.
Okay.
So this part is important. Why we are saying order of 1 here and order of n here, right? This is clear, right, Anjal?
Yeah, this is clear, Karthik.
So similarly, for hash map, we do something called hashing. Hashing is a very useful technique when it comes to hash map. Because of that, only hash map is so much preferred. Um, I'll give you a rough example of how hashing is done. Um, let's say I wanted to store some key value pair. In this example, um, let's say generally key value pair in Java is represented by notations k and v, right? K represents key, v represents value. So whenever you see this k and v in Java, it represents key value pairs. Let's say in this particular scenario, key is integer and value is some string, right? Now, what I'm going to do, let's say I have 5 elements in this hash map. Let's forget about what is in the value. Let's concentrate on key. Let's say those keys are okay. Let's put something like this. Those keys are then 27. Let's say it values is some random string, right? 31. Let's say it represents some country code, right? For example, India's telephone number country code is 91, right? Let's say this is, let's say it's IN, and US is 1, right? 01 US. Let's say I have my hash map like this, key value pair. But how this particular things are stored in a hash map? We have the concept called index in array list. We have a concept called pointers in linked list. But how this particular things are stored in memory in hash map, we have to see that also, right? So whenever we declare hash map, some block of memory, I mean, some set of memory will be blocked in our RAM. So what is just like it will calculate where this data should store based upon something called hash key, right? Let's assume hash key may be anything depends upon what hashing algorithm it is implementing. For simplicity, let's assume this hash key is 11. So a very simple technique of doing hashing over the numbers is like getting the remainder of the values. I'll say what I mean by that. Generally, how will we take a remainder in Java? We'll say the number module symbol you use, right? Modulus, what value we're going to divide. In this case, 11. So we have these keys here: 27, 31, 91, and 01. Let's try to take the remainder of that. So what's a remainder when 27 divided by 11? Remainder is 5, right? 27 by 11, 2 times it will go, remainder will be 5. And 31, remainder will be 22, and 231 is 9, right? And for 91, the remainder will be 11 8 88, and remainder will be 3. For the US, remainder will be 0 because we cannot divide 1 by 11, right? You're getting the point at what you're trying to do. So what it will do, it will always store the particular FE value on the fifth index in that particular memory block which we blocked for creating hash map. And it will always store this DW value in the ninth index. It will always store this IN value in the third index. And it will always store this particular US value in the 0th index. So in our memory location, US will be stored first, and IN will be stored next, FE will be stored next, and DW will be stored last. Although we insert in this order, it will always stored in this order in memory, because this hash value is based upon this hash key, and this is simple implementation of how a hash value is calculated. So whenever I wanted to get this value IN, right, what I will do, I just give let's say hash map dot, there's a some function called get. I'll just give the key value here, hash map dot get of 91. Now what it will do, to search this particular key in hash map, it will just take this hash key, divide it by 11, and remainder it will get. It will directly go to the particular index, that is the third index. Now directly it will go to this third index, and it will take whatever value available in third index, which in this case IN, right? Right? Clear what I'm trying to do?
Karthik, how come the fifth index is US here and the ninth index is IN here?
No. It is not fifth index, right? This is
Okay.
a hash value which is computed after
Okay.
this hash key. A hash value for FE is 5, because um, I mean 27 divided by 11 is 22, remainder will be 5. This 5 represents FE, not US. These are two different things. Forget this.
Okay.
So 0 represents US because I cannot divide 1 by 11. So in our memory location, it will be stored in this order. I'm not equating this to this. These are two different things which I'm trying to
So
say.
how is the order is USINFEDW here?
Because the US is zeroth index, right? In zeroth index only the US value will be stored because remember we got a 0, right? So in our memory, US value will be always stored first because it's in zeroth index. How it's in zeroth index? Because we are trying to divide 1 by 11, remainder will be 0, so it's stored in the zeroth index. And similarly for IN, we divide 91 by 11, it's 88, and remainder will be 3. So the value of IN will be always stored in the third index because its key is 91. This index is assigned based upon whatever key value we have here. See, for storing anything in the memory, we need to have some index value, right? If we have index value, we can access that particular element in a constant time, as we saw in this array list. Right? What we try to access in this array list, we try to access the last element, right? We know what's the index of the last element, so we are able to access that in a constant time. Similarly, to compute the index of an hash map, use something called hash key and compute hash value. This hash value represents the index where this particular element is going to store. In this case, we set remainder has the hash value, right? For FP, we divide by 11 and we get the remainder as 3. So this particular FP will be stored in the third index. So only it's coming as the third element here, right? I hope I'm making some sense.
Actually, I understand this hashing divided by 11 thing, but I'm not able to get the how is the final order is USINFEDW because as per the hash key value, the index we got is 5930. Are we
No, just
making it in
put
a
this in ascending order. That's it. Right? Index will
okay,
be
okay,
always
okay,
in
okay,
ascending order, right?
okay, okay,
So in a memory
okay.
location, it will be always in an ascending order, like 0, 3,
359,
5,
okay.
9. So what's the 0
All
here? 0 is US, right?
US, yeah, right,
Yeah,
got
3
it.
is IN, right? So only it's
Yeah.
storing in this order.
Also, one more thing, Karthik, this hash key 11, matlab, it's a static value for the hash key. Matlab, that is what is we called hashing in Hashmap.
Okay, this 11 is kind of a generic value which we generally use for hashing, but nowadays so many
Okay,
complex hashing algorithms are in place, right?
okay,
11 is kind of very old concept. To understand hashing simply, I just stored 11. There are because,
okay,
for example, let us say we have an integer here as a key, so it's very easy to compute hash value by dividing by 11. What if I have a string value here? What if I have a character here? I cannot go and divide a string and character by 11, right? To get a hash
yeah,
value.
right.
So there are many algorithms to do that. Simple hashing algorithm or unique hashing. There are so many hashing algorithms if you want to explore. So idea behind
Okay,
hashing any hashing algorithm is like you have to do some computation so that you can get a unique hash value like this. So based on this hash value, it is stored in the index memory like this. It's a basic idea.
okay, okay. So,
Yes.
in short, agar if you have to explain like what is hash in Hashmap, so can we say that like by computing with different algorithm and
Different hashing algorithm will get some hash value. So based on that
yeah,
hash value, the things are stored in memory location.
ascending. Okay,
Don't have to necessarily say ascending.
okay,
You
okay,
just say
got
that
it,
things are stored accordingly in RAM in RAM, right?
got it, Karthik.
So because of this particular operation which we are trying to do, for example, I wanted to get this value of in, then I can just divide this by 11. I get the index 3. Directly I can go to this index 3 and get this particular value called in, right? So because of this, what is the time complexity of this hash map to get any value? So can you try to say this?
N that is like 4. They're the fourth element.
No, to get any value in hash map, what will be time complexity. We saw what's the time complexity in previous examples, right? How
Yeah,
many times
right.
it's going to take irrespective of number of elements in that particular ladder.
One.
Yeah, it's one here. Why?
Because here we don't know like how much time it would take for all the elements to fetch.
No, 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 no. It's not one. Is not because of that. One is because we are able to fetch something in a constant time, right? We are
Okay.
there are some 1 lakh elements in this particular hash map. We will be able to fetch any element in a constant time because we know the hash value.
Okay. So the first one, what we have got is like a 0n. That is for like if we have the constant time, like these are the millisecond we can fetch for all these nth element. Then we can use 0n, right?
0n is when you have to access all the elements to fetch a particular element, right? Like we saw in linked list, we cannot go to the end without accessing the head.
Okay, 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 okay. Got it, got it.
So if we wanted to access all the element once and find certain value, then that's called order of n
Okay.
time
Now
complex.
I'm able to relate.
So since this hash map has this time complexity of 1, right, constant time, this time may be anything. It may be 20 millisecond, it may be 200 millisecond, right? But the thing is, it's a constant time. It will not vary depend upon number of inputs, right? So only we call as order of 1. So hash map is kind of very fast in Java. So hash map is kind of normally preferred in Java in many use cases. We'll see some.
वैसे वैसे hash map is an मतलब it is not in an ordered way. It is an unordered way, right? Because of hashing itself, right?
Yes, 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 exactly.
Yeah.
Again, hash map is available in java.util library in Java.
This is a like very new thing I've learned today. I've read hash map a lot of times, but I've never read this hashing concept before.
Okay. This is very, very actually important interview question. If you go for many interviews, what's the hash, how hash map stores value internally, how it's able to retrieve data in a constant time.
Okay.
So whatever data structure you learn, it is
Hmm.
more important to how it is internally implemented. That will make uh, more good for interviews actually.
Okay.
Again, I have an interface called map. We'll come to this. So hash map is a key value pair, right? So I can declare two things here in this angled brackets. What's a key? What's a value? Let's say I have a key of string and value of integer. I'm declaring an object like map here equal. I just say new hash map, right? So I will just import these two things here. Importing from java.util. Right now it's imported. As I said in previous sessions, like this is optional. I can either pass this as string and integer here also, right? Or I can just leave it as blank here. Both works. So now, if I wanted to put something in the hash map, um, let's say map dot. I have this put a method, right, which takes string and integer as well because we declared string and uh, integer as a key and value pair. I have, let's go to that mark example itself. Let's say student one is storing some value as 78. Yes. Right. So now we have entered these things. Now what will happen? It will print. It will put this key value pairs accordingly. It will compute some hashing algorithms for the student one key, student two. We don't know what's hashing algorithm. It is some complex algorithm implemented internally. But understand that it computes some hashing algorithm, puts the 78, 83, 99 according to that algorithm, right? So now we'll try to print this. We'll try to run this program. No, it's printing, right? This is a lambda function to print each and every key and value in Hashmap. Entry set map has this Hashmap has a built-in function called entry set. Will get all the key and value pair, and we are iterating over each and every key and value pair, and we are assigning an object called entry for each and every entry in that particular hash map.
What does this entry icon representing, Karthik?
This entry is kind of a single representation of each and every element in this particular hash map. I'm iterating only, right? So I am iterating each and every element in this hash map. I have to assign some object to that particular element so that I can access its key and value. That object is called entry. It may be any name. It can be some random name like this, right? Just giving some value, assigning some object here so that I can access each and every element and putting that particular element in the object that I have created temporarily for each iteration. This will also work. Right?
So what we call exactly this looping?
This is just I'm just looping. I mean, I'm just iterating through each and every element in the hash map and printing its key and value. That's it.
Okay.
This entry set will give all the elements in the hash map. This for each will iterate through each and every element. And to temporarily put that value, I have to have some placeholder value. Right? This DHJ is a placeholder value where I can temporarily put every single iteration element here. In the first iteration, DHJ will hold this particular value, student 178. In second iteration, DHJ will hold this value, student 183. Right? This is a temporary placeholder object. So I'm just getting that key and value here and printing it. Right? So only we are getting this kind of output. Now you see, right? Okay, here itself we saw that example. We are inserted student one first, student two first, student three. I mean, student two second, student three third. Right? Now, how it is printing? Okay, it's very good example. It's printing student two first, student three second, student one last. Why?
The concept we learned today.
Because of hashing, right? Because
Yeah.
of hashing, the student two index came first because of that hash value is first. We don't know what hashing algorithm it uses, but because of that hashing algorithm only, the student two came first, right? Getting the point at Anshul and everyone.
Yeah, right, Karthik.
So Because of this only, hash map is unordered, and the value may be stored in any order because the hash value of each and every element might be different. Right. And to I'm just printing all the element here. I can get an individual element also. I can just say map dot get, the key is there, right? I can just pass the key and get this here. We'll just try to print this. So it will also print, right? 99, it's printing. So I'll just show an example. What if I have some duplicate key like this? Now the value is replaced, right? So understand that since this key, based on this key only, this hash value is calculated, the key must be unique in Java, this hash map, particular hash map. Otherwise, if the key is not unique, the value, whichever this latest value will be overridden. To make this key unique, we can do an implementation called equals and hash code. Maybe you just go and Google it after this class. We will try to cover that in a later sessions. There's something called equals and hash code. So this particular hash map makes us to put this particular student3 object inside this 100. We can avoid that directly in compile time also by this concept called equals and hash code. Maybe it's very important concept actually. But with respect to automation, I don't know how much it is relevant, because nobody is going to ask equals and hash code in testing interview generally. Maybe sometimes a good companies might ask. So just try to learn this equals and what's the equals and hash code, because what is an hash code we saw, right? Previous example only we saw. Whatever I'm saying hash code is this hash value, whichever the example we saw, right? So just try to see that's a kind of very useful thing. So I have this get method to get a value of each and every key. So let's say what are methods we have. I have this clear method to clear this entire hash map. So I have this compute method to compute the value of key and key value pairs. I can this contain value whether this key is present in this particular hash map or not, right? We saw this entry set, right? Gives all the elements in the particular hash map. We can just check if the hash map is empty or not. Right? This key set gives a list of all the keys, right? Only if I want only keys, then I can use this key set. This put and put all, I can put many objects together in the hash map also. Put if absent method is also there. If some key is not there, then I can put that here. I can remove any value from here. Right? You can replace. I can get the size of the hash map. So these are the general things, right? Maybe I'll try to remove a particular value from here. I just remove the student3 itself. Let's try to print this. The student3 is removed, right? Fine. So let's do one more thing. Let's comment this out and so one important thing to understand is that the key can be null in hashmap. That is also one important concept. but this null value can be present only once in a hash map. If there is another entry with a key null, then it's again a problem as we saw in the previous example. Right? Understand that the key can be null also, but that null can happen only once in a hash map. So far, so good, right, everyone? I posted this equals in hash code to everyone. Just have a look at that after the session, or if you get time. So far so good, right, everyone? Okay. So now we'll see a very common example which was asked to me in so many interviews, even which I will ask in so many interviews. Uh, let's say I'll comment all this out. Uh, you might have heard about this problem. I just wanted to find the frequency of each and every element in the given string, right? Have you heard of this problem?
You mean to say we need to find the duplicacy of each word?
Duplicate, frequency of every element that is occurring. For example, in this particular string,
Okay.
T is occurring only once, H is occurring only once,
Okay.
I is occurring 2 times, right?
Okay.
S is occurring 2 times, A is occurring 2 times, G 1 time, D 2 times, right? Similarly, um, what I want is like I want an output where it says, hey, T is 1 time in this particular string, H is 1 time, I is 2 times, S is 2 times. So getting it right. I want to find the frequency of each and every character in this particular string. You're getting what I'm trying to do with this particular input.
Yeah, we are getting the question, Karthik.
So output should be something like this. T is 1 time and H is 1 time, I is 2 times. So it should go on until what are elements there in this. If it's come to this, yes, again it should say 2 times. Again, this I is there, right? It should not compute the value for I because we have already computed here, right? You're getting the whole point, right? This should be the output. So it can be done in many ways. This is a typical example of how you can solve this problem using a hash map, right? We're getting a little idea how we can solve this using a hash map.
As per my knowledge, we can try to we can try to use map and put each and individual element whenever it comes for each loop, and we can write a if statement, like if that is already there, uh, we can also have a count there, and if that is already put in the map what we have already used,
Mhm.
yeah, something like that we can go on.
Yes, yes, true. You got almost got the answer, Anchal. Right? So if this kind of problems, if you're encountering, it's always good to go for hash map, right? So it's a typical example. It's very very common interview question. It's a typical example of how you are going to solve this as an hash. Well, let's try to solve this. Let's create an map. What will be a key value here for the map?
Key value.
Key will be the character and value will be the frequency of each character, right?
Yeah,
So
right,
key will
right.
be a character and value will be an integer. Why it's an integer? because we have to get the frequency. That is a number, right? We put the hash map. So now I wanted to iterate over this entire string, right? I can just simply use the regular iteration. Int I is equal to 0, I is lesser than news dot length. I can say I plus plus. Right. So I can get the individual character of each and every element using a method called, we saw, right? Caret. We saw, right? So when you use this method, we can get a character at this particular index. In the zeroth iteration, we will get a character at the index 0, which is t, and we'll go on, right? H, I, S. We can split this string as characters, and we can get individual characters like this using this character method, right? And I can just use an if condition here. If my map contains this key, right, then what I can probably do is like I can get its value, right? That is a frequency. I can get its count, right? If it contains the particular key, then I can say getting here, right? What I'm trying to do. If the particular map contains this key ch, which I got from that particular index, then I'm getting its value. That's it. That is the frequency, right? Getting it or not?
Yes, Karthik.
Okay. If it's contained the value, then I'm getting its value. I have to increment its value by 1 and put this particular thing in same here, right? So what I'm going to do, I'm just going to say map dot put. I'm putting the same character in the map. This time I'm just going to do what? I'm just going to do the count plus 1. So if character is already present in the hash map, then what I'm going to do, I'm just getting the value whatever present there. I'm just going to put an incremented value. Increment this count by 1 and put this the same thing in a hash map. Okay. If the particular key is not present in the uh, hash map, then what I should do? I just have to put
Yeah.
what? Put the same character with what value? Default value, which default value 1, right? Because this else part will come when we are encountering the particular character for the first time, right? So only if a particular character encountered, we are initializing its frequency as 1 because already that is encountered, right? If the particular character is encountered second time, then the if condition will be executed. It will get that frequency. Uh, for example, already 1 will be there for the particular character. It is increasing the value by 1 and it's putting the same thing in hash map, right? You're getting the whole point. What we're trying to achieve here.
Yeah.
And again, if I wanted to print hash map, I can use the same thing, right? Um, I can say the characters, and I can say the frequencies. Let's try to run this program and see what is the output. Okay, this is empty because of the space, right? The spacing. The space is coming 4 times, A is coming 2 times, right? 2, right? A is 2 times, S is 2 times, T is 1 time, and D is 2 times, right? Where is D? D is this and this. G 1 time, H 1 time, I 2 times, I here and here, Y 1 time. Finally, O is 2 times because of this two O's. It's very simple implementation of how you can get frequency of each and every element, right? So you're getting the whole point what we're trying to do here. Everyone, I just wanted under your feedback from everyone. Like we're trying to understand what we are trying to do here.
Yes.
Okay, it's very common and important interview question. Very simple implementation of Hashmap we can achieve this, right? Otherwise, if you wanted to do this, it's a very complex operation. If you want to do in a regular for loop and store it somewhere, each and every character. So if it contains that key, you get that value and increment that value by 1 and put it in the same key. If it doesn't contain that key, put that in hash map with the value 1. That's it. Simple implementation, this problem is over. Right? This is one of a classic example of where hash map is used.
Karthik, one basic question. The get function in map we use is to get the value of that map, right?
Get the value of the key of that particular
Of the
entry.
particular.
Yeah.
Okay. Yeah.
Fine, right, Ansel. Or anything is not kind of not clear here. Try to explain that one more time. Ushmita, Dibya, Vinay, is it clear? Okay. So can we wrap up the session? Then
Sure, Karthik. Karthik, there's one request. Can matlab by ending the session, can we discuss what we are about to discuss tomorrow?
okay.
Like we should be prepared or like
We are
something.
going
What
to
is the tomorrow
discuss
topic?
stacks and queues.
Okay, that's great.
Right. I just I do this overview again. There are some more implementation of this map called the linked hash map. Right. We'll just try to do this.
Actually, not sure. Actually, I have missed some sessions previously, and I'm not able to read that sessions. Have you covered arrays?
Yeah, we have covered arrays and linked list in previous sessions.
Okay. 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 That's it.
Okay.
I have one doubt in arrays. Since time is over, can we discuss it tomorrow or something?
Oh, like if it's small thing, we can probably discuss here itself.
Okay, I just want to, I was just reading some programs and all. Since there is an equals function in arrays, so like if I don't want to use an equal function in arrays, can we implement that by ourselves? Like I try to do it by myself by creating two loops. Like one is comparing both the arrays by two loops, but I'm not able to get that answers correctly.
I just wanted to know like what is the problem, because based on that problem only we can see know what's the thing happening, then we can know solution, right?
Okay, I'll discuss it personally otherwise.
Okay. Okay, there are some more implementation of this hash map called linked hash map. Linked hash map is something like it will maintain the insertion order actually, and this hash table. You just see this, and there's something called tree map. Maybe I'll just post this link. Just see this, everyone. Maybe you'll get a better idea. Right? Just try to see this link. We'll discuss personally, Anchal, all right?
Sure, Karthik.
So, can we wrap up the session then?
Yeah, Karthik.
Okay.